All right, so we got to really think about this question here. And so a publisher is selling newspapers for 150 pesos each, and they've been able to sell 80,000 per day. So let's determine. They determined that if they raise the price by 1 peso, then they sell 250 less newspapers. Okay. So first of all, what's their revenue right now? That's how much they're making each day. So we're going to say X is the price rise and R is revenue. So we're going to say R of X equals what? Okay. So their revenue right now is actually, what is it? The number of papers they sell, which times the price. So let's say P. The price is 150. So it's 150 times 80,000. Okay, and so what does that equal to? So that's 12 million. Okay, so that's where they are right now. Now, if X represents the price increase, so I'm assuming that on a graph, this is, let's say this is 12 million. I'll just put 12M. And this is the increase. Okay, this is the X value. So right now at 0 increase, because X is the increase, it's going to increase the revenue, I'm hoping, and then eventually, so we'll reach a maximum revenue. That's what we want to do. Okay, we're going to lose some customers along the way, but we're gaining a lot of profit. Okay, so that we've got 80,000 right now. If we raise it, 1 peso, that's a lot of money. We do lose some customers. So where's that maximum amount? Okay, so what are we going to say? Well, we're going to say our current price, so the revenue is equal to, and it's not going to be 150, it's going to be 150 plus X. That's what we're trying to find out. This is the price, right? This is our price here. So that's this, same thing. This is price. This is the number of sales. Now, the problem with the number of sales is when we increase by X, right, we lose 250. Oops, let me erase that. 250 times X, okay? So that would be our amount there. So 250X. That's how much we lose. Okay, think about that. So we can go ahead and expand this here, and then we could use negative b over 2a to find out that maximum X value, and then what would be our maximum revenue as well. Okay, so this is just distributive property, right? So 150, we know that's 12 million. We already did that, right? And then multiply here, and that is going to be minus 37,500. These are big numbers, but don't worry, it's going to be fine. X, and then this is an easy one, plus 80,000X, and then minus 250X squared. So let's go ahead and collect the like terms. So we've got, we only have 1x squared, so negative 250x squared. Okay, and it makes sense it's a negative a value because this was the model that I kind of like dreamed up over here. Okay, and then we combine. Let's see, minus 80,000. So this is going to be plus 42,500x. All right, and then plus 12 million. Okay, so we know what A, B, and C are, right? So this is A and this is B. And to find the axis of symmetry, x is equal to negative B, so negative 4 to 2,500 divided by 2 times negative 250. It's going to be positive, and then when I work that out, I get x is equal to, well, you probably need a calculator for that, 85. Okay, so I'm going to increase by 85 pesos, right? Now, to find the revenue, what I could do is I can substitute 85 back here. I find it easier. And then also here for x, okay? And when I substitute that out, that's when I'm going to get the maximum revenue. And it should be, the max revenue should be 13,806,250. Alright, so you're going to need a calculator for that one. That's a tough one to do. Did we answer the question there? So we have the maximum revenue here. This is in peso, right? Okay, and then we have, this is the price raise right here, price rise.